Hi everyone, I'm from SK Engineering Limited. Welcome to this demonstration of the Spectrum Pipelines suite of software. Spectrum Pipelines is a set of modules of design and integrity calculations for onshore and subsea pipelines. The software suite comprises 13 different modules, and each module is dedicated to different aspects of pipeline design. Today, I would like to give you a tour of the wall thickness module, which is used for calculation of pipeline wall thickness and code compliance checks for onshore and subsea pipelines. The software is also applicable for offshore risers and piping. The module is activated by double-clicking the application file, which loads all of the software features. The graphic user interface has a very simple and user-friendly layout, which assists users with entering the input data on screen. The user interface is divided into two screens, an input screen and a results screen. Once the input data is inserted and the user hits the Calculate button, the software solver calculates for the required parameters and outputs the results on screen. A PDF results file can also be created and saved locally. The PDF file contains the wall thickness calculation results and code compliance utilization ratios. Firstly, let's take a look at the input screen, which is divided into four sections, which are pipe parameters, process and environmental parameters, allowable stress design code check parameters, and DNV code check parameters. The pipe parameters include the nominal outside diameter and nominal wall thickness. If the wall thickness has already been specified, the user can calculate the wall thickness utilization ratio or code compliance utilization ratio. The pipe properties also include a definition of the manufacturing process, which could be seamless or welded pipe, the manufacturing tolerance, which is either in percentage terms or absolute terms, the corrosion allowance, and pipe variety, such as pipeline or riser. Pipe material properties can be entered either by selecting the material grade from a drop-down box or by directly entering the yield and tensile strength. Thermal derating of the yield and tensile strength of the material is also accounted for in calculations, either by entering thermal derating values directly or by allowing the software to calculate the thermal derating based on the design temperature. Other properties of the pipe material, such as Young's modulus, Poisson's ratio, and yield to tensile ratio, are also entered. Girth weld factor and ovality of the pipe are inserted along with the supplementary U requirement, if applicable. Process and design parameters include pipeline internal pressure, reference pressure for internal pressure, design temperature and system test pressure, if known. If the system test pressure is not entered, the software will calculate this pressure based on the governing code. Incidental to design pressure ratio, minimum pressure, contents density, density of seawater, and minimum and maximum water depth are also required. In ASD code check inputs, longitudinal stress, hoop stress, and shear stress are entered. For DNV code checks, the functional and environmental bending moment and functional and environmental effective axial force are entered for load-controlled checks. For displacement-controlled checks, the functional and environmental strains and load condition factor are specified. If the minimum pressure needs to be considered for code checks, then this also needs to be specified. This completes the input screen. Now, let's take a look at the results screen. The results screen is divided into four sections, which are the wall thickness calculations based on non-DNV codes, the wall thickness calculations based on DNV F101, ASD code check calculations, and DNV F101 code check calculations. The user needs to select the governing code for non-DNV wall thickness calculations. This could be ASME, API, or BS codes. The location class, which is relevant to the ASME B31.8 code, must also be specified at this stage if applicable. When the user hits the Calculate button, the wall thickness satisfying the pressure containment criterion under operating and pressure test conditions, hydrostatic collapse criterion, and propagation buckling criterion are calculated and displayed on screen. Where the user has specified the nominal wall thickness, the wall thickness utilization ratio is also calculated and displayed on screen. For wall thickness calculations as per DNV F101, the user needs to enter the safety class as either low, medium, or high. Again, once the user hits the Calculate button, the wall thickness based on pressure containment under operating and system pressure test conditions is calculated. The wall thickness is also calculated for hydrostatic collapse and propagation buckling criteria. Where the user specifies the nominal wall thickness, the utilization ratios for these criteria are also calculated. For ASD code check calculations, when the user hits the Calculate button, the utilization ratio for longitudinal stress, hoop stress, and von Mises equivalent stress are calculated and displayed on screen. For DNV code check calculations, when the user hits the Calculate button, the wall thickness required to satisfy DCC and LCC code compliance checks is calculated, and where the user has specified the nominal wall thickness, the DCC and LCC utilization ratios are calculated for load combinations A and B. The results sheet, as well as a summary of the input parameters, can be saved as a PDF file. Each project case can be saved and reloaded for editing in the future. Thanks for watching this demonstration of the Spectrum Pipelines Wall Thickness module. For demonstration videos of other modules, get in touch with us at info@engineeringsk.com or inquiries@z-subsea.com. Spectrum Pipelines, making pipeline design and integrity smarter.